Question number 1. The magnitude of the electric force. This is not about electric force, it's a mistyping. It's a magnetic force. So the magnitude of the magnetic force on a charged particle that is moving inside uniform magnetic field is 0. If the angle between the direction of the particle's velocity and direction of the magnetic field is equal to. So if the charged particle moves parallel to magnetic field lines, which means angle will be 0 degrees or angle will be 180 degrees. So magnetic force acting on the charged particle is 0. So answer is D. Question number 2. A proton moving perpendicular to magnetic field of strength 3.5 millitesla experience a force due to the field of 4.5 times 10 to the power negative 21 newtons. Calculate kinetic energy of the proton. Mass of the proton is given. A charge of the proton is given. For calculating kinetic energy, we need to know what velocity of the particle, speed of the particle is. First, we should calculate speed of the particle by using the equation of the magnetic force. So, if a particle moves perpendicular to the uniform magnetic field, magnetic force acting on the particle is equal to Q times V times B. Because we will calculate the V speed first, simplify it by dividing Q and B. Simplify by dividing Q and B. So speed of the particle is going to be force divided by charge of the particle multiplied by magnetic field intensity. So let's first get speed of the particle. Force is given 4.5 times 10 to the power of negative 21. Charge of the proton is given 1.6 times 10 to the power of negative 19. Magnetic field is given as 3.5 millitesla, but every millitesla is 10 to the power of negative 3 tesla, so you should multiply millitesla by 10 to the power of negative 3 to convert Tesla. So then after that, use your calculator. So 4.5 times 10 to the power of negative 21 divided by bracket 1.6 times 10 to the power of negative 19 multiplied by 3.5 times 10 to the power of negative 3, close the bracket. So this is speed of the particle. It is 8 times 10 to the power of negative 6. I think there's a mistake in here. Let's check it again. 4.5 times 10 to the power of negative 21 Newton is the force divided by bracket 1.6 times 10 to the power of negative 19 times 3.5 times 10 to the power of negative 3, close the bracket. So 8, it's 8, not 8 times 10 to the power negative 6, it's 8 meter per second. This is the speed of the particle. Now we are ready for calculating the kinetic energy. We are going to use the equation for kinetic energy. Kinetic energy is equal to 1 over 2 m times v squared. So because proton is moving, we use the mass of the proton and speed of the proton. So 1 over 2 mass of the proton is given in the question as 1.67 times 10 to the power of negative 27 kilograms multiplied by speed is 8, square of 8. Now let's calculate them all. 1.67 times 10 to the power of negative 27 times square of 8, 64 divided by 2 is answer 5.34 times 10 to the power of negative 26 joule. So it is answer B. Question number 3. An electron in electron beam experiences a force of 2 times 10 to the power of negative 14 Newton. So this is the force while traveling perpendicularly to uniform magnetic field. This is B. What is the approximate speed of the electron. Calculate V. V is the question. Charge is also given. So again, we are going to use the equation for magnetic force because it's moving perpendicular to the magnetic field. So equation is Q times V times B. So we will calculate V, simplify Q and B by dividing Q and B. Divide Q and B, simplify them. So V is equal to force divided by Q times B. So speed is equal to force is given as 2 times 10 to the power of negative 14 divided by Q, charge of an electron, 1.6 times 10 to the power of negative 19. Magnetic field intensity 8.3 times 10 to the power of negative 2. Close the bracket. Now use your calculator. 2 times 10 to the power of negative 14. 2 times 10 to the power of negative 14 divided by bracket 1.6 times 10 to the power of negative 19 times 8.3 times 10 to the power of negative 2. Close the bracket. Answer is 1.5 times. It's equal to 1.5 times 10 to the power of 6. 10 to the power of 6 meter per second. So answer is A. Question number 4. In the figure, find the direction of the magnetic force. So we will find direction of the magnetic force on a proton. So it's a positively charged particle moving with a velocity through the magnetic field. The velocity is into the page, no, out of the page, sorry, that. This is V. The direction of the magnetic field is up to the page. So you are going to use your right hand rule. First show direction of the magnetic field, which is up to the page. Forefinger must show up to the page of your book. And then after that, you are going to show the the velocity vector, which is the direction of the particle's motion, out of the page. Your thumb must show out of the page, but don't change direction of the magnetic field. It is up to the page. So because it's a proton, palm is going to show the magnetic force on the proton. So as you see, your palm is pointing to the left of the page. So it's going to be to the left of the page. So you should apply right hand rule to find this. Don't forget, this is representing magnetic field direction, which is up to the plane of the page. Forefinger is up to the plane of the page. Velocity is out of the page. Thumb must show out of the page. And palm is, in this case, palm is pointing to the left. So for proton, palm is the direction of the force. So it is to the left of the page. And question number 5. What will be the magnitude of the magnetic force on an electron once it passes into a magnetic field? So question is about the equation. QVB is the force for calculating a charge which is moving inside a magnetic field. It is proton or electron, it doesn't matter because question is talking about magnitude. Magnitude of a vector quantity always written as positive. So Q times V times B is the equation. Question number 6. A particle with a charge of 0.03 coulomb, so this is Q, experience a magnetic force of 1.5 Newton, this is F, while moving at right angles to the uniform magnetic field. If the speed of the charge is V given as 625, what is the magnitude of the magnetic field the particle passes through? So B is the question in here. So again, you are going to use the equation for maximum magnetic force because right angle. So F is equal to Q times V times B. This times we will calculate B. That's why you should simplify Q and V. Divide by Q and V, simplify QV. So B is equal to force divided by Q and V. Q multiplied by V. So then B is equal to force is given 1.5 newtons. Q is 0.03. V is given as 625. Don't forget the bracket. So now use your calculator. 1.5 divided by bracket 0.03 times 625. Close the bracket. Answer is 28. It is 28. There's no course, just let's calculate again. 1.5 Newton divided by 0.03 multiplied by 625, close the bracket. Answer is no, 0.08. Sometimes I also surprised why I am doing such calculation mistakes. 0.88 Tesla. So this is A. Question number 7. If a positively charged particle, so positive, is moving with an initial velocity, its direction is perpendicular to uniform magnetic field. So path of the particle will be its circular path. If it is perpendicularly moving to a magnetic field, it's going to be a circular path. A negative charge moves counterclockwise in the plane of the page inside a magnetic field. The field is directed. Remember, I made a table in the classroom. So negative if the charge is negative, if the magnetic field is if the out of the page, or if charge is positive, magnetic field is into the page. So in this case, counterclockwise, always counterclockwise. So if charge is negative, the magnetic field is out of the page, and these signs are almost opposite. If the charge is positive, a magnetic field is into the in the first one is the charge is negative, magnetic field is into the page, or charge is positive, magnetic field is out of the page. So this circle is clockwise, and they are opposites, almost opposite, clockwise, similar counterclockwise. So if the negative, and if it is counterclockwise, so we should check negative dot. So the magnetic field must be out of the page. Question number 9. A region in which magnetic force would be measured. Of course, magnetic force is measured in magnetic field. That region is called magnetic field. Without magnetic field, no magnetic force. Question number 10. According to the figure in the right, direction of the magnetic field of a positive charged particle will be. So force is given to the right, as you see. Velocity is into the page. This cross is representing the velocity written here V in. So because charge is positive palm, your palm must show in the direction of the force. Because force is showing to the right, you should hold your right hand and you should show your palm to the right. And thumb is going to show velocity direction. It must be into the page. Yani cross is into the page. Thumb must show into the page. Palm must show to the right. And when I do like this, I see that my forefinger is pointing up to the plane of the page. So this forefinger is representing magnetic field direction. Up to the page is the answer. Question number 11. In the figure, what is the direction of the magnetic force on proton? Proton is positively charged particle. Its magnetic field is into the page, as you see, cross. So your forefinger will show into the page. Velocity is up to the plane of the page. Take your thumb in the direction of up to the plane of the page while keeping forefinger into the page. So then palm is going to show the force on the proton. As you see, if you do like this right hand rule, you are going to see that your palm is pointing to the left. So that's why this proton will move to the left. Answer will be B. Question number 12. At which angle between directional uniform magnetic field and positively charged particle movement the magnetic force on charged particle equals to half of its maximum value? There is a specific angle, 30 degrees, because at 30 degrees sine 30 is 1/2 because of that. So its force is going to be half of the maximum magnetic force. And question number 13. Suppose an electron is chasing a proton up to this page. So a proton and electron is chasing just after the proton up the page. So they are moving up to the plane of the page. So their directions are up to the plane of the page. Then suddenly a magnetic field pointing into the page is applied. So a magnetic field which is into the page will be applied in this region. So these two particles will stay inside this magnetic field. If a charged particle is moving inside a magnetic field, a magnetic force will act on it. But we know that magnetic force on the proton and electron are opposite, because palm is showing the directional magnetic force on proton, opposite of your palm is showing the force acting on electron. So now apply right hand rule. Forefinger is showing into the page because magnetic field is into the page, cross. Thumb is showing out to the plane of the page. Palm is showing to the left of the page, which is the force on the proton. Proton will go to left, but electron opposite of your palm will be to the right. So that's why proton would go to left, but electron would go to right. They will move in opposite directions. One of them will go like this, the other one will go like that. They will deflect in opposite directions. Question number 14. 1.5 Tesla magnetic field, this is B, points north. So directions in this problem will be like this: north, south, east, and west. So magnetic field is to the north, B is to the north. If the electron moves, as electron negative charge moves vertical downward, which means magnetic, its velocity will be vertical downward towards the ground. Yani into the page we will draw it like this. Velocity V is going to be cross. So with a speed of 2.5 times 10 to the power of 7 meters per second. So this is the velocity. What force, magnitude, and direction will act on it? Charge of the electron also given. First, calculate the magnitude of the force, because its velocity is perpendicular to the magnetic field, because the magnetic field is in horizontal, velocity is in vertical, so they are perpendicular. Then magnetic force is maximum on the charge, so use maximum magnetic force equation, Q times V times P. Q is charge of electron is given 1.6 times 10 to the power of negative 19. V is given as 2.5 times 10 to the power of 7. B is given as 1.5 Tesla. Now let's multiply them all. 1.6 times 10 to the power of negative 19 times 2.5 times 10 to the power of 7 times 1.5 equals 6 times 10 to the power of negative 12. So force is 6 times 10 to the power of negative 12 newtons. So you got it directly. I mean, no need to apply right hand rule for magnetic force, because there is no other choice for this question. Only 6 times 10 to the power of negative 12 Newton is in point choice D. But let's apply the right hand rule. Forefinger will show to the north, so your forefinger will show in the direction of the north, which is according to your page up to the plane of your page, and thumb will show into the page. Change your thumb into the page. You will see that opposite of your palm is the force for electron. It is to the left side of, according to east, west, north, south. It is west is left side, east is right side, so it's going to be pointing the west. West is the magnetic force acting on the electron in this problem. Question number 15. A proton moves at a speed of 2 times 10 to the power of 7 meters per second. This is V. At right angles, again right angles, so maximum magnetic force acts on the particle. To a magnetic field of a magnitude, so magnitude of the magnetic field B is given. Find the magnitude of the acceleration of the proton. Of course, for acceleration, first you should calculate the force. Without force, you cannot calculate acceleration. First, calculate magnetic force. Because of this magnetic force, this particle will accelerate. Q times V times P, Q times V times V. Multiply them all for calculating magnetic force. Q for proton is 1.6 times 10 to the power of negative 19. It's given in the question. B is magnetic field intensity of 0.1 Tesla times V, 2 times 10 to the power of 7 meters per second. Use your calculator and calculate the magnetic force. 1.6 times 10 to the power of negative 19 times 0.1 times 2 times 10 to the power of 7. Answer is 3.2 times 10 to the power of negative 13. 3.2 times 10 to the power of negative 13 newtons. Now for calculating the acceleration, use Newton's second law of motion. Force divided by mass of the proton will be the acceleration. 3.2 times 10 to the power of negative 13 Newton is the force. And so the proton is given in the question as 1.67 times 10 to the power of negative 27 in bracket. So 3.2 times 10 to the power negative 13 divided by, in bracket, 1.67 times 10 to the power of negative 27. Answer is 1.9 times 10 to the power of 14 meter per second squared. So C is the answer. Determine the path of the positively charged particle. So it is positive. That is moving on a plane of the page inside the uniform magnetic field directed into the page. Into the page is cross. So positive and cross. Positive and cross. So we are similar. If they are similar, remember counterclockwise. Counterclockwise. So moving in a counterclockwise circular path. Question number 17. It cannot set a resting electron into motion. Magnetic field cannot set an electron or a proton, a charge into motion. They only apply force on charges if charges are in motion, but it is at rest. That's why magnetic field, stationary magnetic field, cannot set an electron into motion. Question number 18. A particle with a charge of 0.02 coulomb Q is moving at right angles. Again, maximum magnetic force acts on it. Uniform magnetic field is 0.09 Tesla, so this is B. If the speed of the charge is 700 meters per second, find the magnetic force. It's very easy. Maximum magnetic force again asked. Q times V times B. Q is 0.02. V is 700 meters per second. B is 0.09 Tesla. Let's multiply them all. 0.02 times 700 times 0.09. Answer is 1.26 newtons. Okay, this is the answer. A proton, charge is given, mass is given, is in a uniform magnetic field. This is the magnetic field intensity B. The proton moves clockwise circle with a tangential speed of 2.8 times 10 to the power of 5. This is V. What is the radius of the circle? So while a charge is moving in a circular path, in here the magnetic force, because magnetic force always perpendicular to velocity, this magnetic force is the centripetal force. We will make them equal, and centripetal force in here is going to be magnetic force. Equation for centripetal force is mass times tangential speed squared divided by radius of the circle is equal to magnetic force Q times V times B. So this V squared and this V will simplify. So then R is going to be M times V divided by Q times B. M is given 1.7 times 10 to the power of negative 27. V is given as 2.8 times 10 to the power of 5 meter per second divided by Q 1.6 times 10 to the power of negative 19. B is 0.25, but denominator must be in bracket. Now use your calculator. 1.7 times 10 to the power of negative 27 times 2.8 times 10 to the power of 5 divided by bracket 1.6 times 10 to the power of negative 19 times 0.25, close the bracket. Result is 0.02 meters, 0.02 meters, and 2 times 10 to the power negative 2 meters. 2.2 times 10 to the power negative 2 meters. So B is the closest answer in here. So B is the correct answer. Okay, this is all about the first title, magnetic force acting on a charged particle. But in this calculation, question number 19 says C, but we found it 2 times 10 to the power negative 2. Let's calculate again. There's a mistake. Sorry, I calculated not 0.02, not 0.02. Just calculator says 0.0119. So if we round, it's going to be 0.012. meter, yani 1.2 times 10 to the power of negative 2 meters. So not B, C is the correct answer for this question. That's all about this title.